Hi everyone. Today we're going to study system of linear equations. Particularly, we will determine whether an ordered pair is a solution. Let us have some introduction. A linear equation in two variables, such as 2x plus y equals 5, has an infinite number of solutions. Each graph is a line. Remember, every point on the line is a solution to the equation, and every solution to the equation is a point on the line. Let us determine whether an ordered pair is a solution. When two or more linear equations are grouped together, they form a system of linear equations. To solve a system of two linear equations, we want to find the values of the variables that are solutions to both equations. In other words, we are looking for the ordered pairs xy that make both equations true. These are called the solutions of a system of equations. To determine if an ordered pair is a solution to a system of two equations, we substitute the values of the ordered pair into each equation. If the ordered pair makes both equations true, then it is a solution to the system. Let us have example 1. Determine whether the ordered pair -2, -1 is a solution to the system. The first equation, x minus y equals -1. Second equation is 2x minus y equals -5. To determine if the ordered pair -2, -1 is a solution, we substitute it into each equation. If the ordered pair -2, -1 makes both equations true, then it is a solution to the system. Let's take the first equation, the x minus y equals -1. Let us now substitute the ordered pair respectively, the -2 to the x and the -1 to the y. So we have now -2 minus a -1 equals -1. Let us simplify. We can remove the grouping symbol, so this -2 will come out as -2, and in here the negative sign and the negative sign becomes positive, so this becomes +1 equals, the right side is still -1. Simplifying the left side, the -2 plus 1 is now -1, and we can see that this is equal to the -1 on the right side. So the ordered pair makes the first equation true. Let's take the second equation. 2x minus y equals -5. Substituting the values respectively, we have now 2 times x becomes -2, then minus y is now -1, and the right side is -5. Simplifying further, 2 times negative 2 will be negative 4. This negative sign and the negative 1 here becomes positive 1. And this is equal to negative 5. Simplifying the left side, negative 4 plus 1 is negative 3, which is not equal to negative 5. So it means the ordered pair negative 2 and negative 1 makes the equation 2 false. So it means to say this ordered pair negative 2, negative 1 is not a solution to the system of linear equations. This is our final answer. Let us have example 2. Determine whether the ordered pair negative 4, negative 3 is a solution to the system. And this is the same system of equations from our example 1. So what we're going to do is to substitute this ordered pair negative 4 and negative 3 into each equation. If the ordered pair makes both equations true, then it is a solution to the system. Let's take the first equation, x minus y equals negative 1. Let us substitute the ordered pair negative 4 and negative 3 respectively. We know that the first number negative 4 is for the x and the second number negative 3 is for the y. So we have here negative 4 minus a negative 3 must be equal to negative 1. Let us simplify the left side. This negative 4 will simply come out as negative 4. The negative and the negative becomes positive. So this is now plus 3 must be equal to negative 1. Simplifying our left side, so we have negative 4 plus 3 is equal to negative 1. And we can see that this value is equal to the right side value, which is also negative 1. So the ordered pair negative 4, negative 3 makes equation 1 true. Let's proceed with equation 2. The 2x minus y equals negative 5. Let us substitute the ordered pair negative 4, negative 3 respectively. So we have now 2 times the x, which is now negative 4, then minus the y, which is now negative 3. And this must be equal to negative 5. Simplifying the left side, 2 times negative 4 is negative 8. And this negative and negative becomes positive. So this is now positive 3 equals negative 5. Simplifying this negative 8 plus 3, we have negative 5. And is now equal to our right side value, which is also negative 5. So this ordered pair negative 4, negative 3 makes equation 2 true. It means to say the ordered pair negative 4, negative 3 is a solution to the system of linear equations. This is our final answer. Today we're going to study system of linear equations, and we're going to solve this by graphing. The graph of a linear equation is a line. Each point on the line is a solution to the equation. For a system of two equations, we will graph two lines. Then we can see all the points that are solutions to each equation. The point of intersection is the solution of the system of linear equations. When we solve a system of two linear equations by graphing, there are three possible cases. Case 1 is intersecting lines, as we can see on the figure. The two graphs intersect in a single point. The coordinates of this point give the only solution of this system. Since the system has a solution, it is consistent. The equations are not equivalent, so they are independent. Case 2 is parallel lines, and our figure here shows parallel lines. There is no solution common to both equations, so the solution set is null and the system is inconsistent. Since the equations are not equivalent, they are independent. Case 3 is the graphs are the same line. And in this figure, we can see one line, but it represents both graphs of both equations. Because we have just one line, there are infinitely many solutions. This type of system is consistent because there is a solution. The equations are equivalent, so they are dependent. Let's have an example. Solve the system by graphing. The first equation is 2x plus y equals 7. The second equation is x minus 2y equals 6. Our step 1 is to graph the first equation. So this first equation we will copy here, and then let us find the intercepts. For y-intercept, we set x equals 0. Thus, the equation 2x plus y equals 7 becomes 2 times 0 plus y equals 7. And we can cancel this 2 times 0. So we can now have y equals 7. This is the value of y when x equals 0. So the ordered pair of y-intercept is 0, 7. For x-intercept, we set y equals 0. Thus, the first equation now becomes 2x plus 0 equals 7. We can ignore the 0 here, so we have 2x equals 7. Let us find the value of x. Let us divide the whole equation by the coefficient of x, which is 2. So we have now x equals 7 over 2. This is the value of x when y equals 0. And let us write the ordered pair of x-intercept as 7 over 2, or we say 3.5, 0. Now, let us draw the line. Let us plot the intercepts. The x-intercept is the point where the line touches the x-axis. So this point 7 over 2, 0 is this point. While the point 0.7, this is the y-intercept, the point where the line touches the y-axis, and this is the point. And then let us connect these 2 points by a line. So this line here is the graph of the first equation. Now let's go to step 2, and that is to graph the second equation. Let us copy the second equation here, and then let us find the intercepts. For y-intercept, we set x equals 0. Thus, this equation x minus 2y equals 6 now becomes 0 minus 2y equals 6. We can ignore the 0 here, so we have this negative 2y equals 6. Let us find the value of y. Let us divide the whole equation by the coefficient of y, which is negative 2. And if we do that, this negative 2 will be deleted from y. So we have now y equals 6 over negative 2. And when we simplify this, we will get the value negative 3. So the ordered pair for the y-intercept is 0, negative 3. Now for x-intercept, let us set y equals 0. Thus, this second equation, x minus 2y equals 6, now becomes x minus 2 times 0 equals 6. And this 2 times 0 can be cancelled out. So we have now x equals 6. Let us now write the ordered pair for the x-intercept. So we have here 6, 0. Now let us graph the line for the second equation. First, let us plot the 2 points or the intercepts in our rectangular coordinate system. So we have first the x-intercept is 6, 0, and here is the point, and the y-intercept is 0, negative 3, and this is the point. We connect these 2 points by a line, and this line now is the graph of the second equation. So step 3, determine whether the lines intersect, are parallel, or are the same line. In this example, the 2 lines intersect at the point 4, negative 1. And this is the solution. Can you see here? That is the point of intersection, which is 4, negative 1. And this is our final answer. Example 2. Solve the system by graphing. 3x plus y equals negative 3. 2x plus 3y equals 5. Let us graph the first equation. We have this 3x plus y equals negative 3. Let us find the intercepts. Let's begin with the y-intercept. We set x equals 0. So the equation here becomes 3 times 0 plus y equals negative 3. 3 times 0 is cancelled out, so we have y equals negative 3. We write the point that will be 0, the x coordinate, and the y coordinate is this negative 3. Then we go for the x-intercept. We set y equals 0. For this equation, we have now 3x plus 0 equals negative 3. Or simply we write 3x equals negative 3. We divide this equation by 3, so we have x equals negative 3 over 3, and this is negative 1. And that would be negative 1, 0. X coordinate is negative 1, while y coordinate is 0. Now, let us plot the points and let us draw the line. This is the point negative 1, 0, while this is the point 0, negative 3. Let us connect these 2 points by a line. This is now the graph of the first equation. Now let us graph the second equation. We have this 2x plus 3y equals 5. Let's find the intercepts. Let's begin with the y-intercept. We set x equals 0. This equation becomes 2 times 0 plus 3y equals 5. 2 times 0 is 0, so we have 3y equals 5. Then we solve for y. We have y equals 5 over 3. So the first point is 0, 5 over 3. Then we go for x-intercept. We set y equals 0. So this equation becomes 2x plus 3 times 0 equals 5. 3 times 0 is cancelled, so we have 2x equals 5. Let us solve for x. So x equals 5 over 2. We can write now the point. So 5 over 2, 0. Let us plot these 2 points, then we connect the 2 points. This is the 0, 5 over 3, while this is the point 5 over 2, 0. We connect the 2 points by a line. This is now the graph of the second equation. The step 3 is to look out for the point of intersection, and that is the solution. Look at the 2 lines. They intersect at this point. So we say that the 2 lines intersect at the point -2, 3. This is the answer. Today we're going to study solution by substitution method. Given a pair of linear equations in 2 variables, here are the steps of substitution method. Step 1. Find the value of one variable, say y, in terms of the other variable, that is x, from either equation, whichever is convenient. Step 2. Substitute this value of y in the other equation and reduce it to an equation in one variable, that is in terms of x, which can be solved. Step 3. Substitute the value of x or y obtained in step 2 in the equation used in step 1 to obtain the value of the other variable. Example 1. Solve by substitution method. X plus 3y equals 6. 2x minus 3y equals 12. Step 1. Find the value of one variable from one equation, whichever is convenient. Let this be our first equation. This is the second equation. Look at our first equation. We can isolate x in one side, meaning this positive 3y we will transpose to the right. So we have x equals 6 minus 3y. Then step 2. Substitute this value of x in terms of y in the other equation, meaning in equation 2, and reduce it to an equation in one variable. Our equation 2 is 2x minus 3y equals 12. This x here we will change by 6 minus 3y. So it becomes 2 times 6 minus 3y, then minus 3y equals 12. Simplifying, this 2 multiplied to 6 becomes 12. 2 times negative 3y is negative 6y. Then we copy this negative 3y equals 12. We combine this negative 6y and negative 3y. Also, the 12 here we will transpose to the right. So we have negative 9y equals 12 minus 12. The right side becomes 0. We solve for y. We divide this equation by negative 9. So the value of y equals 0. This is the value of our y. Then we go to step 3. Substitute the value of y, which is 0, obtained in step 2, in the equation used in step 1 to obtain the value of x. So our equation 1 is x plus 3y equals 6. We substitute the value y as 0 in here. So equation 1 becomes x plus 3 times 0 equals 6. 3 times 0 is simply 0. So the value of x is 6. This is the value of x. Example 2. Solve by substitution method. 2x plus 3y equals 9. 4x plus 6y equals 18. Step 1. Find the value of one variable from one equation, whichever is convenient. We assign this as the first equation. This is the second equation. Look at our first equation. Let us try to isolate y in one side, meaning this 2x we transpose to the right. It becomes negative. And then we divide the equation by 3, then y will be isolated. So equation 1 becomes y equals 9 minus 2x all over 3. Then step 2. Substitute this value of y in terms of x in the other equation, which is equation 2, and reduce it to an equation in one variable. So equation 2 is 4x plus 6y equals 18. The value of y here we will change in here. So equation 2 becomes 4x plus 6y. And 6y is now changed into 9 minus 2x all over 3. Then equals 18. The denominator 3 here can be cancelled out with the number 6. So it becomes 2. Then we multiply this 2 to the 9 and to the negative 2x. So we have 18 minus 4x. We copy this 4x down here and then equals 18. This 4x and negative 4x become 0. So we have 18 equals 18. Note that the variable x is cancelled out, but the equation is still true. 18 equals 18. If this is the case, the pair of linear equations has infinitely many solutions. Example 3. Solve by substitution method. X plus 2y minus 4 equals 0. 2x plus 4y minus 12 equals 0. Step 1. Find the value of one variable from one equation, whichever is convenient. This is our equation 1. This is the equation 2. Look at equation 1. We can isolate x and we can express this in terms of y, meaning this 2y and negative 4 we transpose to the right. So x equals 4 minus 2y. Then step 2. Substitute this value of x in terms of y in the other equation and reduce it to an equation in one variable. Our equation 2 is 2x plus 4y minus 12 equals 0. The value of x we will put here as 4 minus 2y. So equation 2 becomes 2 times the quantity 4 minus 2y. Then we copy plus 4y minus 12 equals 0. We simplify further. 2 times 4 is 8. 2 times negative 2y is negative 4y. Then plus 4y negative 12 equals 0. We simplify negative 4y plus 4y becomes 0. 8 minus 12 is negative 4 equals the right side value 0. Note that the variable y is cancelled out, but the equation is false. We see here negative 4 equals 0 is false. If this is the case, the pair of linear equations has no solution. Today we're going to study system of linear equations, and we're going to solve this by elimination. To solve a system of equations by elimination, we start with both equations in standard form, meaning the x and y variables are on the left side and constant on the right side. And there will be two equations. And this is the standard form of a system of linear equations. Now, we will decide which variable will be easier to eliminate. Once we choose the variable to be eliminated, this is what we're going to do. We want to have the coefficients of one variable, and that is the variable that we chose to eliminate, to be opposites, so that we can add the equations together and eliminate that variable. This process is what we call elimination by addition. Given a pair of linear equations in two variables, here are the steps of elimination method. Step 1. Multiply both the equations by some suitable non-zero constants to make the coefficients of one variable, either x or y, numerically equal. Step 2. Add or subtract one equation from the other so that one variable gets eliminated. Step 3. Solve the equation in one variable, x or y, so obtained, to get its value. Step 4. Substitute this value of x or y in either of the original equations to get the value of the other variable. Note that in step 2, if we obtain a true statement involving no variable, then the original pair of equations has infinitely many solutions. Also, still in step 2, if we obtain a false statement involving no variable, then the original pair of equations has no solution. Example 1. Solve by elimination method. X plus 3y equals 6. 2x minus 3y equals 12. Observe the coefficients of each of the variables. Let's copy our problem down here. Notice that the coefficients of y are numerically same, but of opposite signs. In this case, we can add the equations. When we add, the y variable will cancel out. Then x plus 2x is 3x equals 6 plus 12 is 18. And then we divide by 3. That is the coefficient of x. So that we will get the value of x equals 6, because 18 divided by 3 is 6. So we have now the value of x. Now we substitute the derived value of x into any one of the equations. Let's say the first equation. This is x plus 3y equals 6. X becomes 6 plus 3y equals 6. This 6 here we transpose to the right. It becomes negative 6. Then the right side becomes 0. We divide the equation by 3 so that y equals 0. This is the value for y. So we are done with our problem. X equals 6, y equals 0. Example 2. Solve by elimination method. 2x plus 5y equals negative 8. 3x minus 4y equals 11. We copy our problem down here and let us observe the coefficients. Note that the coefficients of each of the variables are numerically different. In this case, we can decide which variable to eliminate. Let's say x. We're going to multiply equation 1 by coefficient of x in equation 2. That is the number 3, and vice versa. It means the first equation we multiply by 3, the second equation we multiply by 2. So the equations becomes like this. The first equation multiplied by 3 becomes 6x plus 15y equals negative 24. Second equation multiplied by 2, it becomes 6x minus 8y equals 22. Now we see that coefficients of x respectively are now numerically same. Therefore, we will subtract the equations. Remember, when we subtract, we need to change the sign of the terms of the second equation. The 6x here becomes negative, negative 8y becomes positive, the positive 22 becomes negative. Then we proceed to addition. 6x plus negative 6x is cancelled. 15y plus 8y is 23y. Negative 24 plus negative 22 is negative 46. And we want to get the value of y, we divide the equation by 23. So y equals negative 2. We have now the value of y. Then we substitute the value of y in any of the equations to get the value of x. Let's say equation 1. So 2x plus 5y equals negative 8 becomes 2x plus 5 times the negative 2 equals negative 8. 5 times negative 2 is negative 10. Then we transpose the negative 10 to the right. So 2x equals negative 8 plus 10. The right side becomes positive 2. To solve for x, we divide the equation by 2. So x equals positive 1. This is the value of x. Example 3. 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. How old are Nuri and Sonu? We let x to be Nuri's age. Y equals Sonu's age. Now the condition 1, 5 years ago, Nuri was thrice as old as Sonu. Let us represent the 5 years ago with respect to the age. So for Nuri, that is x minus 5. For Sonu, that is y minus 5. And it says, Nuri was thrice as old as Sonu. So to balance this, we will multiply 3 to Nuri's age. Then let us simplify the right side. 3 times y is 3y. 3 times negative 5 is negative 15. From here, we transpose 3y to the left. This negative 5 we transpose to the right. So we have x minus 3y equals negative 15 plus 5. Right side becomes negative 10. Now condition 2. 10 years later, Nuri will be twice as old as Sonu. Again, we represent the age of Nuri as x plus 10. The age of Sonu 10 years later will be y plus 10. It says again, Nuri will be twice as old as Sonu. So we multiply 2 to the age of Sonu. Then we simplify the right side. 2 times y is 2y. 2 times 10 is 20. Then this 2y we transpose to the left. The positive 10 we transpose to the right. So we have x minus 2y equals 20 minus 10. The right side becomes 10. So we have now the two equations. This is equation 1 here. This is equation 2. Let's put them together. Now we can see that coefficients of x are numerically same. We can subtract the equations. In doing so, we need to change the sign of the terms of the second equation. X becomes negative, negative 3y becomes positive, negative 10 becomes positive. Then we add. X plus negative x will cancel out. Negative 2y plus 3y is y. 10 plus 10 is 20. So this is the value of y. We said that y is Sonu's age. It means Sonu is 20 years old. Let us substitute the value of y in any of the equations. Let's say the first equation. The x minus 3y equals negative 10. So we substitute it here. X minus 3 times 20 equals negative 10. Negative 3 times 20 is negative 60. We transpose this negative 60 to the right. So x equals negative 10 plus 60. And the right side becomes 50. So x equals 50. In the beginning, we said that x is Nuri's age. So, Nuri is 50 years old. An example. Solve the system of linear equations by elimination. We have the two equations. The first is 2x plus y equals 7. The second is x minus 2y equals 6. There is a note that if any coefficients are fractions, clear them first by multiplying the equation by LCD, or the least common denominator. But in our example here, there is no fraction. So let us proceed with step 1. Check out which variable is easier to eliminate. We have the variable x respectively for the two equations and the variable y for the two equations respectively. And our goal here is to make the coefficients of the chosen variable to be same but opposites, meaning they are of opposite signs. Let us copy these two equations down here. Let us name them to be first equation and second equation. As for our discussion, I would like to eliminate y for the reason that they are already opposite signs. However, they have different coefficients. So let us do some manipulation. This is the general rule. Multiply the first equation by the numerical coefficient of y in the second equation, and vice versa. It means to say, since I decided to eliminate y, in the first equation, I will multiply the first equation by the coefficient of y in the second, which is 2. And in this case, I will not include the sign. And also, for the second equation, I will multiply this by the coefficient of y in the first equation. and in this case it is 1. So we have now the first equation to be multiplied by 2 and the second equation to be multiplied by 1. Simplifying the equations, we have this 2 times 2x will be 4x and 2 times y is 2y equals 2 times 7 is 14. While the second equation, if we multiply by 1, will just be the same. That is the x minus 2y equals 6. And from here, let us add. Look at our variable y. We have positive 2y and negative 2y that we can simply eliminate or cancel. And then let us add the x and the x. So we have 4x plus x will be 5x. And the right side, this is now equal to 14 plus 6 is 20. Now let us solve for x. Let us divide this equation by the coefficient of x, which is 5. If we divide this equation by 5, the coefficient of x will be 1, which means we can simply copy the x down here, and on the right side, we have 20 divided by 5. And simplifying this, the quotient is 4. So we have a value of x as 4. And then, let's go to step 2, and that is to substitute this value of x to any of the original equations to get the value of y. So we have two equations here. Suppose we choose the first equation, the 2x plus y equals 7. And then, let us now substitute the 4 to that x. So we have 2 times 4 plus y equals 7. This 2 times 4 will be 8 plus y equals 7. Let us transpose the number 8 to the right side. The sign must be changed. So this is positive, it becomes negative. So we have now y equals 7 minus 8, and this is equal to negative 1. So y equals negative 1. Let us write the x and the y as an ordered pair. So we have 4, negative 1. And this is the solution of our system of linear equations here. Now let us check if this answer is correct. Let us substitute the solution to both equations and must make those equations as true. Let us take the first equation, 2x plus y equals 7. Let us substitute the 4 into the x and the negative 1 to y. So we have now 2 times 4 plus negative 1 must be equal to 7. 2 times 4 is 8 plus the negative 1 equals 7. 8 plus negative 1 is 7 and equal to the right side, which is 7 also. So the 4 negative 1 makes the first equation true. Let's try the second equation. The x minus 2y equals 6. Let us now substitute the values. So now the x becomes 4 and this y here becomes negative 1. So we have 4 minus 2 times negative 1 must be equal to 6. So this is now 4. This negative 2 times negative 1 will be positive 2 equals 6. And 4 plus 2 is 6 and that is equal to 6. So it is correct. So again, the solution makes the second equation true. It means to say, we are sure that our answer here is correct. And this is our final answer. Example 1. Determine if the following points are solutions to the given system of equations. We have 2x minus 6y equals 0, 3x minus 4y equals 5. We have here 2 points. Let's begin with point A, 3, 1. We shall substitute the coordinates to the two equations and see if it satisfies both equations. So we substitute x equals 3 and y equals 1 to both equations. Let's begin with the first equation. 2x minus 6y equals 0. Upon substituting, we have 2 times 3 minus 6 times 1 equals 0. 2 times 3 is 6 minus 6 times 1 is 6 equals 0. 6 minus 6 is 0 equals 0. So equation 1 is satisfied. What about equation 2? 3x minus 4y equals 5. It becomes 3 times 3 minus 4 times 1 equals 5. 3 times 3 is 9 minus 4 times 1, that is 4, equals 5. 9 minus 4 is 5 equals the right side 5. So equation 2 is satisfied. Then both equations are satisfied. That means this 3, 1 is a solution. Second point, negative 3, 4. Now we substitute x equals negative 3 and y equals 4 to both equations and see if it satisfies these equations. Let's begin with the first. 2x minus 6y equals 0. It becomes 2 times negative 3 minus 6 times 4 equals 0. 2 times negative 3 is negative 6 minus 6 times 4 is 24 equals 0. Negative 6 minus 24 is negative 30. That is not equal to the right side value, which is 0. We see here that equation 1 is not satisfied. So we stopped here and we conclude that the negative 3, 4 is not a solution. Example 2. Solve the following system of equations by graphing. Negative x plus y equals 2. 2x plus y equals negative 4. We're going to graph the two equations, and the coordinates of the point of intersection is the solution of the system of equations. Let us graph the first equation. Let us find the intercepts of the line. At first, we set x equals 0 and solve for y. We will get the y-intercept. So, the negative x plus y equals 2 becomes negative 0 plus y equals 2. We can remove this negative 0 and we have y equals 2. So, the first point is 0, 2, or we say this is the y-intercept. Let's solve for the x-intercept. We set y equals 0 and solve for x. The negative x plus y equals 2 now becomes negative x plus 0 equals 2. We can remove the 0. This negative x equals 2. We multiply by negative 1. Or we say that x equals negative 2. So the second point is negative 2, 0. Or we say that this is the x-intercept. Let us now plot the 2 points and connect this to form the line. This point 0, 2 is here. The point negative 2, 0 is here. Connecting the 2 points, we have this line representing this first equation. What about the second equation? Also, we find the intercepts of this line. We set x equals 0 and solve for y. So 2x plus y equals negative 4 becomes 2 times 0 plus y equals negative 4. This 2 times 0 is cancelled out, so we have y equals negative 4. So the first point is 0, negative 4, or we say this is the y-intercept. What about the x-intercept? We set y equals 0 and solve for x. So this 2x plus y equals negative 4 is now 2x plus 0 equals negative 4. We can remove this 0. Then this 2x equals negative 4. We divide by 2. So we get the value of x as negative 2. The second point is negative 2, 0. This is the x-intercept. Now we plot the 2 points. This 0, negative 4 is here. And this negative 2, 0 is again coming here. Then we connect the 2 points. We form the line of the second equation. Now we see that this point, negative 2, 0, is the point of intersection. So we conclude this negative 2, 0 is the solution. Example 3. Solve the following system of equations by graphing. Y equals x minus 2. Y equals negative 3x plus 2. Let us graph the first line. So we find the intercepts of this line. We set x equals 0 and solve for y. So y equals x minus 2 becomes y equals 0 minus 2, or simply y equals negative 2. The first point is 0, negative 2, or we say that this is the y-intercept. Then the x-intercept, we set y equals 0 and solve for x. So this y equals x minus 2 becomes 0 equals x minus 2. We transpose the negative 2 to the left. It becomes positive, or we say that x equals 2. So the second point is 2, 0. This is the x-intercept. Let us now plot the 2 points. 0, negative 2 is here. 2, 0 is here. We connect the 2 points by a line. So this is the line representing the first equation. We go to the second equation. Let us graph this. Let us find the intercepts of this line. We set x equals 0 and solve for y. So this y equals negative 3x plus 2 becomes y equals negative 3 times 0 plus 2. This negative 3 times 0 becomes 0. So y equals 2. The first point is 0, 2, or we say this is the y-intercept. What about x-intercept? We set y equals 0 and solve for x. So this equation becomes 0 equals negative 3x plus 2. Let us solve for x. This negative 3x we transpose to the left, becomes positive. Then we divide the equation by positive 3. So x equals 2 over 3. The second point is 2 over 3, 0. Let us now plot the 2 points. This 0, 2 is here, and the 2/3, 0 is here. Connecting the 2 points by a line, we have now this second line for second equation. Take note that the point of intersection is here, that corresponds to the point 1, negative 1. So we say that this 1, negative 1 is the solution. Example 4. Solve by substitution. 2x plus y equals negative 4. 3x minus 2y equals negative 6. Let us name the first equation to be equation 1, the second equation to be equation 2. For equation 1, let us isolate a variable, let's say y. We transpose this 2x to the right, so it becomes negative. Equation 1 becomes y equals negative 4 minus 2x. Next is, we substitute this y value to equation 2. So this becomes 3x minus 2 times the quantity negative 4 minus 2x equals negative 6. We simplify this negative 2 times negative 4. It becomes positive 8. Negative 2 times negative 2x, positive 4x. Then we combine 3x and 4x. It becomes 7x. And this positive 8 we transpose to the right. It becomes negative. So we have 7x equals negative 6 minus 8. And the right side becomes negative 14. We want the value of x. We divide this equation by 7. Or we write x equals negative 14 all over 7. And the quotient is negative 2. So the value of x is negative 2. Let us solve now for y. We substitute the value of x in equation 1. We can use this equation here. So y equals negative 4 minus 2 times negative 2. This negative 2 times negative 2 is positive 4. Negative 4 plus 4 is 0. This is the value of y. Example 5. Solve by substitution. X minus 2y equals negative 5. 2x minus 3y equals negative 4. We name the first equation to be equation 1 and this is equation 2 respectively. In equation 1, we isolate a variable, let's say x. This negative 2y we transpose to the right. So we have x equals negative 5 plus 2y. Then we substitute this x value to equation 2. So equation 2 becomes 2 times negative 5 plus 2y minus 3y equals negative 4. We simplify this 2 times negative 5, it becomes negative 10. 2 times positive 2y is positive 4y. And we combine 4y minus 3y. We get positive y. We transpose the negative 10 to the right. So we have negative 4 plus 10. And the value is 6. This is the value of y. Let us solve for x. We substitute the value of y in equation 1. Or we can use this equation here. X equals negative 5 plus 2 times 6. 2 times 6 is 12. Negative 5 plus 12 is positive 7. So x equals 7 and y equals 6. Example 6. Solve by elimination. 5x plus 2y equals to negative 3x minus y equals 0. The first equation is equation 1 and the second is equation 2. We are going to choose which variable to eliminate. Look at the variable y. Here is 2y. Second equation have negative y. We can choose to eliminate this y variable. What we're going to do is we multiply 1 by coefficient of y in 2 and vice versa. So for first equation, we multiply this by 1. The second equation, we multiply by 2. The first equation becomes 5x plus 2y equals 2. So there is no change. we multiply it by 1, while the second equation becomes negative 6x minus 2y equals 0. Then we can see that first equation have positive 2y, second equation becomes negative 2y. Because of the opposite signs for 2y, we're going to add this equation. When we do that, this 2y and negative 2y will be eliminated. Then 5x plus negative 6x. We have negative x equals 2 plus 0 is 2. We multiply this by negative 1, or we write x equals negative 2. This is the value of x. Let us now solve for y. We substitute x equals negative 2 to any of these two equations. Let's say equation 2. So we have negative 3 times negative 2 minus y equals 0. Negative 3 times negative 2 is positive 6 minus y equals 0. This negative y we transpose to the right. So 6 equals y, or we write y equals 6. So these are the values. Y equals 6 and x equals negative 2. Example 7. Solve by elimination. 3x minus 5y equals negative 9. 5x plus 2y equals 16. First equation, second equation, respectively. Let us choose which variable to eliminate. We can choose x or y. This time we choose x. So we multiply equation 1 by coefficient of x in equation 2, and vice versa. In equation 1 we have 3x, while in equation 2 we have 5x. That means in equation 1 we multiply by 5. In equation 2 we multiply by 3. When we multiply the first equation by 5, it becomes 15x minus 25y equals negative 45. The equation 2 becomes 15x plus 6y equals 48. Now look at the 15x in both equations. They are equal and same sign. In this case, we're going to subtract the equations. When we subtract, we need to change the signs of all the terms of the second equation. This is now negative 15x, negative 6y equals negative 48. Then we proceed to addition. 15x plus negative 15x is 0. Then negative 25y plus negative 6y. We have negative 31y equals negative 45 plus negative 48. That is negative 93. We divide this equation by negative 31, so we write negative 93 over negative 31. And this is equal to positive 3. This is the value of y. Let us now solve for x. We substitute y equals 3 to any of the equations. We can choose equation 1. So equation 1 becomes 3x minus 5 times 3 equals negative 9. 5 times 3 is 15. And this negative 15 we transpose to the right. So 3x equals negative 9 plus 15. The right side becomes positive 6. We divide this equation by 3. So x equals 6 over 3 or positive 2. This is the value of x, 2, and this is the value of y, which is 3.